Okay, so hemostasis is a multi-step process of which we will talk about, and it includes our coagulation cascade, and there are numerous components that go into hemostasis. The first one is our platelets. We've talked about platelets before. We have what we call plasma clotting factors. We have naturally occurring anticoagulants in our body. So we hear a lot about people who take anticoagulants because of certain conditions, but our body actually has naturally occurring ones so that our whole vascular system doesn't clot. And our endothelial lining in our blood vessels also plays an important part in this whole process. So those are our four main components of hemostasis. Okay, so next let's kind of break the components down. Our first one is going to be our platelets. So we also call them thrombocytes, and normally in our body, our regular platelet level should be anywhere from 150,000 to 450,000. And again, this is one of those labs that a lot of times we'll hear it referred to as, oh, well, the platelet count is 200 or the platelet count is 14, which really means 200,000 or 14,000. Platelets have a lifespan of about 10 days, and then they undergo apoptosis or scheduled elimination. We store about 1/3 of our platelets at any time in our spleen, and they kind of hang out there until they're needed or until they die off. Platelet production, or how we make platelets, is controlled by something that we call thrombopoietin. And this is a protein, and it's a protein that has no nucleus. Okay? The next thing that's important is the cell membrane of the platelet, and it's an important part in the adherence of the platelet and the coagulation process. So if we talk about our membrane, this is the membrane of the platelet. It helps with adherence in that whole process, and it's because the surface is covered with what we call glycoproteins. Okay, so this has kind of three important roles. So platelets in general, their first role is to form a plug. So they're going to plug the injured blood vessel, and how they do this is they start to kind of clump together and they become swollen, sticky, and they actually become spiky. And they also start to secrete things. Alright, and that's how that initial clot is formed. It's just to plug so that we don't bleed too much. The second thing is that they help constrict the damaged blood vessels. And if you remember the whole inflammatory process, part of that process is vasoconstriction, and platelets actually help with this. The third thing that our platelets do is they, again, like I said, they secrete certain things. So they're going to provide substances that accelerate clotting. And these substances are factors, and we're going to talk a lot about factors. They secrete factor 3 and factor 13. Alright, and also what we call platelet factor 3. So different than just factor 3, but platelet factor 3. So those are the three important parts that our platelets play in the whole hemostasis. So the next component that we'll talk about is our plasma. Okay, so plasma contains another protein, and it's what we call plasminogen. And plasminogen is eventually turned into plasmin. And what plasmin helps do is it will dissolve a clot and prevent inappropriate clotting. So that's one of those things that's going to prevent our whole circulatory system from becoming clotted. We also we talked about coagulation factors, and we're going to talk about this more when we talk about the coagulation cascade. But we have these different factors, and most of them are proteins, and they're synthesized in the liver. So when we have someone who has liver damage or liver failure, they also have bleeding issues as well. And one of the things that is necessary for the synthesis of certain factors is vitamin K. So vitamin K is necessary for a couple things. It is necessary for us to synthesize factors 3, and our factors are always written in Roman numerals, factor 9, factor 10, and then some of those plasma proteins, which are our prothrombin, and protein C. And if you're a little confused, this is going to make more sense when we put our coagulation cascade together. Another very important component in our hemostasis is calcium. So calcium is needed almost at every point of our coagulation cascade. It's also referred to as factor 4. So we need it pretty much in any step. Now, the thing to remember is that a clot is not a permanent thing. A clot is meant to be temporary. So part of this whole process after hemostasis has occurred and a clot has formed is actually the dissolving of the clot. And we'll talk about that as well in our 5 steps of the process. So the next part we're going to talk about is our endothelium. And if you remember from the inflammatory process, the lining of our endothelium and our blood vessels plays some very important parts. So most of the time, our endothelium is going to promote our blood flow, and it's going to prevent clotting. Remember, we want our cells to move along our vessels very smoothly. But in certain processes, such as an inflammatory process, it's activated. And it's activated by several things. One is cytokines. And the cytokines are released or activated in response to an injury of sorts. So this is kind of how our endothelium helps. So now we'll talk about the 5 stages of hemostasis. And this is clot formation and dissolution. And if you look in your book, there's a good visual, if you're a visual person, pages 266 and 267. Oops. Alright, so talk about the 5 stages. The first stage, and what we've talked about before, is vessel spasm. Okay, so that vessel spasm happens when injury occurs to the endothelium, and it usually happens very quickly. Just like we talked about in inflammation, it happens usually in less than a minute. And what it does is it decreases that blood flow, because we don't want a bunch of blood flowing out of that injured cell. We want to conserve it. The second stage is the development of that platelet plug. So our body's going to try to plug that hole as quick as it can. And this is initiated as these platelets hit that vessel wall where it's damaged. And basically what it does is it will seal small breaks. So obviously if we have a massive trauma or something like that, we're going to need additional help. Our platelets aren't going to be able to handle. It's attracted by the damaged vessel, and those platelets change from a very smooth disc. So if you think about platelets, they're usually very smooth and rounded, but they turn into kind of these spiky things so that they can adhere and stick a little bit better to that area. And then they expose those glycoprotein receptors. Okay. So this is where our glycoproteins come in. So in order for that platelet to really adhere, so they've opened those glycoprotein receptors, they've made themselves spiky and sticky, but they need one more thing, and that is what we call von Willebrand factor. And we can abbreviate it like that. So, von Willebrand is again a protein. It's produced by our megakaryocytes and endothelial cells. And it circulates as a carrier. So it's a carrier. Oops. For, you guessed it, another factor. And that is factor 8. So then, remember those glycoprotein receptors have kind of come out. So now the platelet membrane binds to the von Willebrand at the site of the injury. Okay, so our von Willebrand is going to bind with platelets at the injury site. And ultimately what's going to happen is it's going to link our platelets to collagen. Collagen fibers. Alright. Now platelets also secrete two other substances. Oops, that should be an L. They secrete ADP, or adenosine diphosphate, and also something TXA, which is a prostaglandin. Alright, and those are going to come in handy here shortly. So together, these two items, our ADP and TXA, cause an expansion of platelet aggregation, which is going to help with that primary hemostatic platelet plug. So they're going to help gather all those platelets to the site of injury and help form the plug. Alright, so we end up with a hemostatic platelet plug, is what we call it. Alright, this platelet plug is what becomes our clot, what we know as a clot. Okay? Or a clot is a secondary hemostatic platelet plug. And this all happens as our coagulation pathway is activated, and we have fibrinogen that turns into fibrin and makes this mesh work. Okay? If you think about fibrin as fabric, fibers in fabric. So it makes this mesh work and acts as a cement for the platelets and all of these other components, and ultimately helps with that clot. Now there are certain drugs that we can give to inhibit this process. So on someone that you are afraid of clotting too much, we can give them things like aspirin, heparin, warfarin, all sorts of things that would help with this process, or help process not happen. So the third and the most important part is our coagulation cascade. Okay, so our coagulation cascade is the stepwise process, and basically, again, we're turning fibrinogen into fibrin strands, and we can have this activated by intrinsic and extrinsic pathways. And now all of these steps have to occur in the same order for this to happen. So if we talk about intrinsic pathways, so an intrinsic pathway is a slow process. Alright, and it begins in our circulation, and it begins with the activation of factor 12. So intrinsic, inside the body. Extrinsic is much faster, and it begins with trauma to a blood vessel or tissue, and then there's this release of this tissue factor called thromboplastin. Or factor 3. They're one and the same. They're interchangeable. So once this is activated, they become located to the injury site. And again, remember, now our body is going to release those natural anticoagulants so that our entire vascular system doesn't clot. So if we kind of draw this out, and I'll do it the best I can here, our intrinsic pathway, we'll just abbreviate it I. And remember, this is going to be starting inside the blood system, and it's contact with a damaged vessel. So we have a damaged Now we do a lot of converting of factors here. So the first thing that we're going to do is we're going to take factor 12 and convert it to factor 12A. Okay, then we're going to take factor 11 and convert it to factor 11A. Then we're going to skip one and take factor 9 and convert it to 9A. And then our last factor on this side that we're going to convert is factor 8. And you guessed it, it's going to be converted to factor 11A. So that is the slow one. And you can see why it's so slow, because it has to go through a number of factor conversions. Now our extrinsic pathway, or our faster pathway that's going to deal with damage to tissue, and remember, we release the thromboplastin, and that's basically all it's going to release. And now together they share a common pathway. So now the rest of the process is going to be the same. So if we look at our common pathway, the first thing that's going to happen is we're going to need a bunch of calcium, because calcium is going to facilitate all of the rest of this process. And now we're going to do some more converting. We're going to convert factor 10 to factor 10A. This is going to help us synthesize factor 5. And factor 5 is going to help us produce our platelet phospholipid. Which in turn is going to help us produce our prothrombin. So once we have our prothrombin, sorry, let me erase here. Alright, so I have my prothrombin. This is going to help stimulate an enzyme, and it's going to turn into thrombin. Now thrombin's going to do two things. The first, it's going to help synthesize fibrinogen. The next thing it's going to do is help synthesize factor 13. And yes, we are going to convert it to factor 13A. So our fibrinogen is going to be converted to fibrin with the help of factor 13A. And our fibrin, again, is our final product, which creates a stable fibrin clot. And remember that fibrin kind of makes that mesh work for all those other things to really solidify that clot. So the coagulation cascade is step 3 in this whole process. Okay, this is going to be the Chapter 12 lecture. Chapter 12 is on disorders of hemostasis. So, what is hemostasis? So, hemostasis is the stoppage of blood flow, and this is something that normally occurs in our body when a seal is produced in a blood vessel to prevent blood loss. So, if you cut yourself, there's this process that happens that causes hemostasis so that we don't bleed to death.